Assalamualaikum warahmatullahi wabarakatuh. My name is NAJMUDDIN binti Muhammad. My nature ID is FP19022 and my partner is NIVASINY and perempuan SELLATHURI. Nature ID FP19057. So we will present our project and the project is by using option 2, which is by using voltage regulator LM7805 and LM7905. So the contents that we will present in this project, which is the objectives, introduction, methods, results, discussion, and conclusion. So firstly, for the objectives, the first one is to develop a voltage regulator of LM7805 and LM7905. The second one is to convert 240 volt AC supply into 12 volt DC supply using transformer and diode. And the third one is to obtain an output of positive 5 volt and negative 5 volt from LM7805 and 7905, LM7905 respectively. So for the introductions, voltage regulator is an electricity regulations device designed to automatically convert voltage into a lower, usually direct current constant voltage. The term may refer to a voltage regulator integrated circuit (IC), which is often found in computers and other electronic devices that are plugged directly into an alternating current (AC) wall outlet but require only a small DC voltage. The term can also refer to voltage regulation or power module devices such as cell phone and laptop chargers. Some regulators do not increase or decrease a device's voltage but merely ensure constant output value. So we get into the methods. It will be divided into three parts, which is components and tools that we use, circuit diagram, and step by step. So the components that are being used in this project, which is voltage regulator itself, like LM7805, one, voltage regulators LS709, 7905, diodes IN4000, for 4 of it, capacitors 1000 microfarad, 25 volt, capacitors 10 microfarad, 50 volt, connectors 2 pins per terminal, connectors 2 pins per terminal, generator first PCB, transformer of 12 volt and 500 milliampere, resistor of 68 ohms, LED is which is in red color, and the connecting wire. So these are the components that we are using in our project. So the tools that are being used is soldering gun and stand, soldering iron, soldering paste, screwdriver, long nose plier, and wire cutter. And this is for the circuit diagram that we have shown in the proposal earlier. So in this circuit diagram, we can see that the DC supply, which is 140 volt, that will be transformed by the transformer to be 12 volt AC supply, and then we will get the output voltage is positive 5.005 volt and negative 5.663 volt. And this is the simulation that we have run by multi-C. So for the step-by-step method, firstly is to prepare the components and tools needed as shown in 2.1 and 2.3 respectively. Second one is to mark the places on the PCB where the components to be placed. And the third one is to place components on the marked place on PCB board correctly. Fourth, to connect the connecting to cut the connecting wire according to the length needed to connect the components in the circuit. Then bend the end of wire and place it on the PCB. Fifth is to solder the components and connecting wires linked to the PCB. Seven is transformer was connected to the connectors at PCB, and the power was supplied to the circuit. And lastly is to output connectors were tested with multimeter and the output value was evaluated. My partner NIVASINY will continue with the results, discussions, problem faced during this project and conclusions.
Today I am going to explain the overall process involving in our circuit. One of the test conditions must have for LM7805 is the input voltage supply. The amount of input voltage supply given to this circuit is 12 volt. The range given in the datasheet of LM7805 is within 7.5 volt and 20 volt, whereas the input voltage supply given to LM7905 is negative 12 volt. The range given in the datasheet of LM7905 is within negative 7.5 volt and negative 20 volt. There are several processes involving in this circuit. First is the stepping down process occur in the transformer. The voltage is stepped down from the primary voltage to the secondary voltage, which is here the 220 volt, which is our house current. It's converted to 12 volt using the transformer. Next, the second process involved in the circuit is the rectification. A rectifier is an electrical device composed of one or more diode that converts alternative current to the direct current. A diode is like a one-way valve that allows an electrical current to flow in only one direction. Here, the diode 194007 is used and it works as a rectifier. The third process involved in the circuit is smoothing. To smooth the output of the rectifier, a reservoir capacitor is used. It is placed across the output of the rectifier and in parallel with the load. The smoothing works because the capacitor charges up when the voltage from the rectifier rises above of the capacitor, and then as the rectifier voltage falls, the capacitor provides the required current from its stored charge. Next, the fourth process involved in the circuit is regulation. Regulator provides a constant output voltage for a varied input voltage. In this circuit, we use two voltage regulator, which is LM7805 and LM7905. LM7805 voltage regulator provide a positive voltage output and the range of the output is within positive 4.75 volt to 5.25 volt. Next is this LM7905. This voltage regulator provides a negative voltage output. The range of the output is within negative 4.75 volt to negative 5.25 volt. Later, I will check the output with the multimeter. The fifth process involved in the circuit is more likely same like the third process after the rectification, which is the smoothing. The smoothing works because the capacitor charges up when the voltage from the voltage regulator rises above that of the regulator, and then as the regulator voltage falls, the capacitor provides the required current from its stored charge, which is here. Next, the process involved in a circuit is indicator. For indication process, we include 5 mm LED. If there's a current flow, the LED will light up. Here, we can indicate whether the current is flowing or not. At the same node, we used a 68 ohms resistor for the LED to light up, which is here, the resistor and the LED. Lastly, there are 3-pin screw terminal. One of them are the output terminal for LM7805. The second one is the ground terminal. And lastly, the output terminal for LM7905. Here we will test the output voltage value of both LM7805 and LM7905. Let me on the current. If we see here, the LED lights up, which means the current is flowing. Now, I'm going to open the multimeter. and check for DC. Okay. Now I'm going to test the output of LM7805. The output we get is 4.983 volt. Next, I'm going to test the output voltage for LM7905. The output we get is 5.039, which is within the range that given in the datasheet. Thank you.
Next is the problem phase, troubleshooting and solution. Once we're done with the circuit, we do test with the multimeter. But we accidentally cross-testing the probes, causing the circuit to be shorted. As we short the output of an efficient transformer, the secondary current already be very high and the transformer get overheated and be damaged. Here we replace the transformer with a new one. Before testing it, after the replacement of the new transformer, we didn't on the power supply. For safety purpose, we tested the connection of the circuit with the multimeter. Unfortunately, we shorted the circuit between the diode and the capacitor. There we received 0.00 volt and this means the circuit is shorted. So, we found out the shorted area and rearranged the connection. Lastly, after all connections are corrected, we test the output with multimeter and we managed to get the output which is within the range value in the datasheet. Next is the conclusion. In conclusion, we believe that we already achieved the objective for the project. We also understand the whole process occurring in this circuit. After the regulation and the indication process, we use the multimeter to test the output of LM7805 and LM7905. Here, we already learned how to use a multimeter. Okay, and lastly, the output we receive for both LM7905 and LM7805 are positive 4.975 volt and negative 5.039 volt respectively, and it is within the range that given in the datasheet of the both voltage regulator. Thank you.
And I think that it's from our group, for me and Bapani, NIVASINY. So thank you very much for listening.